Hello and good evening everyone. I am Okkar Sawant. I am PhD student from IIT ISM Danda. I will be the TA for this course Numerical Methods, and I will be solving problems based on the topics which are taught in this course. I will conduct problem solving session in each week and will solve the problem based on the topics which are taught in that respective weeks. Today is the demo session in which I will be solving problems based on solution of linear systems. Solution of linear system. That is, problems in general we can write in the form Ax is equal to B. So what is A? A is the coefficient matrix. X is the unknown matrix which is to be found out or to be calculated, and B is the constant matrix. So this is the basic idea about system solution of linear systems and how we represent it in the matrix form. Now first we will see matrix inversion method. Matrix inversion method. This comes under the category of direct method. This is direct method of finding the values, the solution of linear system. Why it is direct method? Because without any number of iteration we get directly the values for the unknowns. So as we know, the general form is Ax is equal to B. By pre-multiplication of A inverse on both sides, we will get A inverse Ax is equal to A inverse B, that is x is equal to A inverse B. This form will be used for matrix inversion, as A inverse A is the identity matrix. So we will solve one problem based on this. First problem is, we will consider a system of equation 2x plus 3y plus 3z is equal to 5, x minus 2y plus z is equal to minus 4, 3x minus y minus 2z is equal to 3. So here what is our coefficient matrix is 2, 3, 3, 1 minus 2, 1, 3 minus 1 minus 2. Our constant matrix is y minus 4. Next, as we know, in matrix inversion, to find out unknown, we need x is equal to A inverse B. That is, we have to calculate A inverse. A inverse can be calculated as 1 upon determinant of A into cofactor matrix of A, the whole transpose. A inverse is calculated as 1 upon determinant of A into cofactor matrix A, the whole transpose. And this is our solution by matrix inversion. So first we will find out determinant of A. Determinant of A. How will you find out determinant of A? So we will write first A matrix. So it's 2, 3, 3, 1 minus 2, 1, 3 minus 1 minus 2. So determinant of A is given as 2 into, we will close first 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 row and first column. So what remains is minus 2, 1 minus 1 minus 2 plus for second value we will do minus 1 into 3 and will close for second value we will close second, it is the value on the first row second column, so we will close first row and second column. So what we will get is 1 1 3 minus 2 and finally 1 minus 2 minus 1. When we calculate this, get 2 into 4 minus of minus 1 is 4 plus 3 into minus 2 minus 2 minus 3 minus 2 minus 3 minus 5 into minus 3 plus 3 into 1 minus of minus 1 minus of minus 6, that is plus 6. So 10 plus 15 plus 15 is equal to 40. Determinant of A is 40. Now we will calculate cofactor matrix. Cofactor matrix of how we will calculate. In cofactor matrix, we need to find out values on this, say A11, A12, A31, that is 32, 33. That is first row first column, first row first column, first row second column, first row third column, and like this. So how these are calculated? Cofactor A mat of A, we calculate it. So when we calculate the first element is A11. So we will close first row first column and we'll write the remaining things. What is the first row first column? 2 3 3. First row first column is first row first column is first column first row. We get minus 2 1 minus 1 minus 2. So we will write minus 2 1 minus 1 minus 2. This is your first element of the matrix. Second element. In second element, it is first row second column. Then we will close first row and second column. We have to close first row, second column. What we will do, close first row and second column. Whatever is remaining, 1, 1, 1, 3 minus 2. Right? Right. 1, 1, 3 minus 2. Likewise, we will calculate all the remaining elements like first row, third column. In first row, third column, what we will get? First row and third column. First row, third column. So 1 minus 2, 3 minus 1. 1 minus 2, 3 minus 1. Okay. Similarly, second row, first column, we will get second row, first column. Second row, first column is this. Second row, first column. So if we close this, we get 3, 3 minus 1 minus 2. 3 minus 1 minus 2. Then second row, second column, we get second row, sorry, second row, second column, we get second row, second column, what we will get? Just to avoid the confusion, I am erasing this. Okay. So second row, second column element, second row, second column element. How we will get? Closing second row, and second column. We get 2, 3, 3 minus 2. 2, 3 minus 2. Second row, third column. Second row, third column. Second row, third column. 2, 3, 3 minus 1. 2, 3, 3 minus 1. Similarly, we can write the remaining elements as 3, 3 minus 2, 1, which is your third row, first column, 3, 3. Third row, first column, 3, 3 minus 2, 1. Writing cofactor matrix, right? 3, 3. Third row, second column. Third row, second column. What we'll do? Third row, we will close third row. Second column, we get 2, 3, 1, 1. 2, 3, 2, 3, 1, 1. And last element, third row, third column. What we get is third row, third column. Third row, third column, 2, 3, 1 minus 2. 3, 1 minus 2. Now, only thing is we have to remember very important step. Elements which are elements which are on the first row, second column, second row, first column, second row, third column, and third row, second column are negative. So we will put negative values, negative, and negative. This is the final cofactor matrix. calculate final cofactor matrix. Okay, so cofactor matrix is so matrix is minus 4 minus of minus 1 minus 4 minus of minus 1, sorry, 4 minus of minus 1 is 4 plus 1 4, then minus 2 minus 3 is minus 5, and minus of minus 5 is again 5, then minus 1 plus 6 is again 5, then minus 6 plus 3 is minus 3, minus of minus 3 is 3, then minus 4 minus 9 minus 4 minus 9 minus 4 minus 9 is minus 13, then minus 2 minus 9 is minus 11, minus of minus 11 is plus 11, 3 minus 6 minus of minus 6 is 3 plus 6 is 9, 2 minus 3 minus 1 minus of minus 1 is 1, minus 4 minus 3 is minus 7, minus 4 minus 3 is minus 7. So this is our factor matrix A. Now what we need is transpose of this cofactor matrix. We need transpose of this cofactor matrix. As we know, the formula is A inverse is equal to 1 upon determinant of A. We have calculated determinant of A as 40 and transpose of this cofactor matrix. So cofactor matrix we have got what we have got as a cofactor matrix. 5, 5, 5, 3 minus 13 11 and 9 1 minus 7. So taking the transpose, we know we will interchange rows with the columns. So 5 5 5 will become column. So 3 minus 13 will 9 1 minus. So what is your A inverse? A inverse is 1 upon determinant of A, that is what we have calculated is 40. So you can see here we have calculated this earlier, 40 upon 40 into transpose of cofactor matrix A, that is 5 3 9 5 minus 13 1 5 11 minus 7. So we can calculate now the final solution given by inverse B, which is equal to 1 by 40 5 3 9 5 minus 13 and 5 11 minus 7. And what is our constant matrix B? Our constant matrix B is 5 minus 4 3. So 5 minus 4. Now as we know, this is 3 by 3 matrix, this is 3 by 1 matrix. So final matrix will be of size 3 by 1. Okay. So final value 1 by 40 into 3 by 1 matrix, right? So the multiplication will be this row B matrix and so on for each. So 539 is 5 into 5 25, 25 plus 3 into minus 4 is 12, 9 3s are 27, the first element, then 5 into 5 into 5 25 again, then minus 13 into minus 4 is plus 52, and 1 plus 3 is 3, then 5 into 5 25 again, 11 into minus 4 is minus 4, minus 7 into 3 is minus 21, getting 1 by 40. So 25 minus 12 plus 27, how much it is? It's 40. 25 plus 52, 355 plus 25 is 50. And 25 minus 44 minus 21 is 40. It's minus 1. Therefore, x is equal to 40, 80 minus 4. It's 1, 2, minus 1. So, our final solution is x is equal to 1, y is equal to 2, z is equal to minus 1. It's the solution of the given linear system of equations. So, this is the problem based on matrix inversion method. Briefly, we can recap as what we did is we basic form we used Ax is equal to B. So for matrix inversion by pre-multiplication by A inverse we get X is equal to A inverse B. We have calculated A inverse B by formula 1 upon mod A is determinant of A into cofactor matrix of A and its transpose whole transpose, which completes the matrix inversion method. Second, we are going to see another method of solving the system of the linear equations. So another method we will see is the indirect way of the solving this solution of linear system. These are also called as iterative methods. So I am going to take second problem on Gauss-Jacobi method. Gauss-Jacobi method. So let us see. We consider one example to understand this how to solve this by this method. So 20x plus y minus 2z is equal to 70. 3x plus 20y minus z is equal to minus 18. 2x minus 3y plus 20z is equal to 25. So as we know, this is indirect method. Direct, also can say iterative. iterative method. Okay. First Jacobi method. So as we know, general form x is equal to b. So we know what is the A. A is the coefficient matrix. So what are the coefficients? Coefficients are 2, 1 minus 2. Sorry, 20, 1 minus 2. Then 3, 20 minus 1. Then 2 minus 3, 20. And what is our B matrix? Matrix is constant matrix, which is 17 minus 18, 25. 17 minus 18. Okay. Now, here in this, we will try to find out each variable from each equation. Like from first equation, which is 20x plus y minus 2z is equal to 17, which will give us x as 17. Just go go from left hand side to right hand side and equate it with x. So 17 plus 2z minus y upon 20 is the equation to find x. Second equation will be used to find y. Second equation we used to find y. Second equation is 3x plus 21 x plus 20 minus z is equal to minus 8. So this will be used for y. Similar like x, we will also find y minus 18 plus z minus 3x upon, sorry, okay. Then we have system of equations. So system of three equations and three unknowns. So third equation will be used for third variable. So third equation is 2x minus 3y plus 20z is equal to 20. So we will extract z from this as z is equal to 25 plus 3y minus 2x upon 20. What we will do in Jacobi? Now we will consider one initial case. We will consider one initial case values. So initial case values, as this is a iterative method, we will consider initial case values will be required. Initial case. We will consider all as 0. Now, for first iteration, calculate values for first iteration. First iteration, equation of x. What is the equation of x? 17 plus 2z minus y is equal to 20 upon 20. It's x1 is equal to 17 plus 2z0 minus y0 upon 20. Substituting the value zeros for z0 and y0, you get 17 by 20, which comes approximately 0.85. Then similarly we will find out y1 from y equation, its value on the value of the y for first iteration, that's minus 18 plus z0 minus 3x0 upon 20. Substituting the value 0, we will get minus 18 by 20 is equal to minus 0. Again, then z1, value of z1 for first iteration, which is 25 plus 3y0 minus 2x0 upon 20. Substituting values 0, y0, at y0 and x0, we get 25 by 20, which is equal to 1.25. Now, again, we have to take second iteration. Okay, add some pages here. Okay. Okay. We got values for first iteration. We will do for the second iteration. Now, here we are solving for each iteration. So, for how many iteration we have to solve? Till we will get a stabilized value. What do you mean by stabilized value? The values of the particular iteration for particular x, y, or z variable should not be changing much as compared to the values in the previous iteration. That is, the values on the next iteration and values in the previous, or we can say values on the present iteration and values in the previous iteration. The difference should be very small. So for second iteration, we can calculate the value similarly. X2 is equal to 17 plus z1 minus y1 by 20. So now, what is the value of z1? Z1 is 1.25 and y1 is minus 0.0. So x2 is 1.0. Then we find out y2. What is the value of y2? Minus 18 minus 3x1, right? Minus 18 minus 3x1 plus z1 upon 20. Right? So minus 18, what is the value of x1? 0.85. So minus 18 minus what is x1 value 0.85 plus z1 value is 1.4. So y2 is, if we calculate this, we will get minus 0.65. 0.965. Similarly, we will calculate value of z for second iteration, which is we will calculate 25 plus 311 minus 2x1 upon 20. 25 plus 3 into y1. Y1 value is minus 0.9 minus 2. What is x1 value is 0.85. 0.85 upon 20. So value of Z2 comes out to be 1.1575. Now we'll see the difference. There is much difference. The difference is very high between the x1 and x2, also between the y2 and y1, and also between z1 and z2. So we have to do the further iterations. So now we can do further iterations like by making some table. So consider this table as say variable, okay, so that the initial value and the iteration and the number of iterations. So what we will do, we will just make one table, okay. We will make a table for we will have value of x y z. Initial value is 0 0 0 as we have taken. Then we will calculate value for each iteration. For first iteration, for second iteration, for third iteration. So just give me time. Okay. Now we will find out values for first, second, different iteration till we get the stabilized value. Okay. So we'll take this is first iteration value. Then we will find out second iteration value, third iteration value. Based on calculation, what we are getting is for first iteration we are getting 0.85 minus 0.9, 1.25. Similarly, when we calculated second iteration, we got 1.02 minus 0.965 and 1.157. Likewise, when we will keep on calculating based on second values, we will so values on the second iteration, we will get values on third iteration, which I have pre-calculated, which are 0.0134, which you can try on your own, 9954 and 1.00. Now you can see the difference between the values of the x between the two consecutive iteration is getting reduced. So we will try to do the iteration till it gets the value, the difference between the values so small that it will not be that significant. So again I have computed values for further iterations. 4 and 6. Okay, values I have computed which you can try on your own. For fourth iteration is 1.0009, sorry, 1.0009 minus 1.0098, 0.999. Okay, then for fifth iteration is x is 1.000, y is 1. N minus 1.002 and Z is 0.9996. Again, for sixth iteration, based on fifth iteration value, we get x value 1.000 minus 1.000 and 1.000. That is value after fourth digit after the decimal is not changing till the third decimal is not changing. So the difference is of order 10 raised to minus 4 if we see the values in the fifth iteration and sixth iteration. So this is very small error and is acceptable. That's why we can consider these values in the sixth iteration as the solution. So solution is x is equal to 1, y is equal to minus 1, z is equal to 1. Same thing you can try for the problem which we have solved using matrix inversion method. It is not necessary that the number of iteration required to get value will be very large or very small. It depends on that system of the equation. So these are the two problems which I have projected to solve in this demo session. I hope you understand what I have explained. If you find any difficulty, you can keep your doubts and ask me in the next session. Thank you so much for listening to me, and whenever it is needed, please let me know. Any you have doubt. Okay, thank you. I'm ending up this session here.